Hello students, in this session we will discuss about the object relational and extended relational systems. So in the previous two sessions of module 2 we were discussing about the object oriented databases in general and the various ways in which we can deal with the different objects that are that can be used as a storage for the database applications. So here will be we as we know, we were discussing about object oriented systems alone. Now it is not always possible to always work with this object oriented database system alone. So normally we are not familiar with this object oriented database system, not in a complete way. So what we are doing is the relational database system, which was already there in the form of SQL and SQL standards supported databases like Oracle, MySQL, etc. So in this relational database management system, we are having a standard SQL, and we are having different versions of this SQL available. So here in this session we are discussing about a new system that is the combination of object oriented databases and relational databases. So relational databases deals with rows and columns representation of datas, means attributes and values, rows and columns, and object oriented databases deals with objects and it type constructors and dealing with objects for reference to the different datas. So it will be a better choice if we are combining the traditional relational database concept into object oriented database also, so that we can partially utilize relational concept as well as whenever we require objects we can utilize the concept of object also. So that is why we are discussing about this object relational database system and some extended relational system. That means the existing relational system like SQL is being extended so that the object oriented features can also be added into that particular system. So let us see the object relational features. We are going to combine both object as well as relational database features. So as all of you know, SQL is the basic standard that was followed in relational database system, and it was invented in the year 1970. So that situation, SQL was purely based on the table like structure, and we are dealing with different tables, different entities and attributes where we are combining different relations, for example company, students, employees, etc. We are creating these tables in the form of rows and columns, and we are querying these databases by using the SQL standard operations like DDL, DML, etc. So it was actually invented during 1970s. Now later, as you know, like any other language, SQL was also enhanced, and it was enhanced during 89 and some more enhancement added during 1992. And later we can see that a new standard which is called as SQL 3, that is traditional SQL is being extended or enhanced to form SQL 3, which is being added with some object oriented features also. So what we are doing is this SQL 3 is a new relational standard where we are having some features of object oriented system is also being added. So in SQL the relational concept combined with object oriented concept to form SQL 3 standard. So SQL is the basic traditional standard for only relational database system, and SQL 3 is an enhanced standard which is being added with object oriented features also. And there is a subset called as SQL 99 which was part of SQL 3. So SQL 3 consists of a subset which is called as SQL 99, which is basically or many commonly or that is commonly used with object relational database concept. So we are going to discuss in detail about this SQL 3 and SQL 99. Now let us see the different components of SQL standard, which is means we are going to discuss about the SQL 3. We will discuss about the components of SQL 3 standard. So the basic components are, so we are not going to discuss in detail about all these components. We will be describing about what are the different components available or what are the different features available that is part of an SQL 3 standard. So some of the components are, it consists of SQL framework. SQL framework deals with the place where we are dealing with the databases. Maybe in Oracle you can see an SQL framework where we can enter SQL queries. So SQL framework is the place where we can enter various SQL queries. So which will be having some features, how to enter all these data, how we can access those elements, how we can enter these queries, how we can take the reports. All these things are available which is part of SQL framework. Now similarly we are having SQL Foundation. So in the next slide we will discuss what are the different components that are present under SQL Foundation. Then we will be discussing about SQL bindings, what we mean by SQL binding. Then SQL object. So we will be describing about these two. Now SQL object means the SQL 3 standard which deals with object. So we will be having different objects being created. So for dealing with these objects we are using a component called as SQL object, that is also part of an SQL 3 standard. Now the SQL 3 standard also consists of some temporal aspects as well as transaction aspects. Temporal, as you know, it deals with history of data. History of data in the sense the history that consists of the date along with the exact time of the occurrence of a particular data entry or event. Similarly, the various transaction operations that are also part of the SQL 3 standard. Similarly, we are having two more components. One is SQL call level interface called as SQL CLI and SQL PSM, that is persistent stored modules. So we will be describing about SQL Foundation, SQL binding, SQL CLI and SQL PSM in our upcoming slides. So these are the main components that are a part of SQL command. So we are not going to discuss in detail about how this SQL 3 is working. So we are not having any practical session. So we are simply looking into the different components in theory point of view, and we will see some examples how we can create different elements or how we can deal with these datas or objects that are created within this SQL 3 standard, and we will see some basic SQL queries that are dealing with these objects as well as relational database concepts. Now SQL Foundation. So one component of SQL standard is SQL Foundation. SQL Foundation consists of various further sub-elements. So SQL Foundation deals with the different portions. What are the different types of SQL statements that we are using, or what are the other details that are added into the SQL 3 new standard. So it consists of new types or new data types so that it can be adopted with object oriented features. So like when we are dealing with attributes with certain types, especially for objects, it is not always possible with traditional SQL standard. So SQL 3 or SQL 99 is added with some more new types. We will see some of the types in our future examples. So that is being added into SQL Foundation. Then we are having some new sets of predicates. Predicates means certain conditions. So when we are dealing with objects, like if you are having some conditions to be met for accessing some particular object or element from the database, we need to utilize some certain types of predicates or conditions. Predicates means, like in our traditional relational databases, we are having the conditions like where roll number equal to 1, that is a predicate. Similarly, in order to associate with objects, we are having some more new sets of predicates being added into the SQL3 as part of SQL Foundation. Now we are having some relational operators for comparison, like less than, greater than, etc., for comparing different objects or elements that are present in this object relational databases. It also consists of some rules and triggers. Some certain rules can be adopted to some existing database, where the rules will be followed according to the requirement. Like a rule example is giving a particular attribute as a key attribute. That is a rule implemented into a particular database system. So if that is being given there, always the rule must be followed. Similarly, triggers are a special category of rule that must be executed according to the occurrence of some certain event. So triggers we will be discussing in our third module in detail, the way in which how we can create triggers and what are the different types of triggers and what are the different features of triggers we will be seeing separately. So rules can be any rules that can be added, like it can be called as a constraint also. Triggers are special type of rules that rules must be adopted as and when some event occurs within the database system. Now similarly, the SQL Foundation consists of user-defined types. The user or we can create our own types. Other than built-in types, we can create our own types. It is just like creation of a new class. Creation of a new class is like creation of a new type that we are familiar in the case of an object-oriented language like C++, where we are creating a new class. Creation of a new class is equivalent to creation of a new user-defined type. Then SQL Foundation also consists of some transaction capabilities. In order to deal with several number of queries, a transaction normally consists of several steps, like beginning the transaction, then read or write operation, then commit, abort, etc. For all these, we are having the different provisions available for dealing with all these steps in SQL Foundation of SQL3 standard. And similarly, we are having some stored routines, that is built-in functions or stored routines, built-in procedures are available, so that we can utilize those routines as and when it is required. So stored routines are required in our SQL statement whenever we want to execute some statements that are already built in. So these are the various components as part of SQL Foundation, which is a common component present as part of SQL3 standard. Now we will see what is SQL CLI, call level interface. Call level interface, SQL CLI, which is the short term for call level interface. It stands for SQL call level interface. SQL call level interface. So it is just like a function call in our traditional language. So as you know, in C and all or C++, we are having some functions which are predefined. So we can call this call level interface can also be considered as predefined functions or methods. So it provides rules that allow execution of application code without providing its source code. That means by using simply the name of that particular method or operation, we can execute some certain number of source code without knowing the internal details how it is being implemented. So we can write a function, it can be stored it within the library, and we can simply call that function by using the call, or by calling that particular function by using its name. So without knowing the internal details, we can execute that particular function. So call level interface provides the facility for accessing or executing a particular operation or function without knowing the internal details. So the advantage of this SQL CLI is it avoids the need for pre-processing. So whenever we require some function to be executed, it is already pre-processed and it is stored within the library. So every time when it is being called, we don't actually require a pre-processing. It can be directly executed as and when it is being called. So this SQL 3 or SQL 99 standard contains around 50 routines, that is 50 built-in functions or routines for doing certain tasks. For example, one example routine is like if you want to provide a connection to SQL server. If you want to connect with SQL server, for that particular connection there will be a call to function available or call to routine available, which is already predefined, and directly it can be executed when we are using that particular routine. So SQL call level interface is one of the major component of SQL standard. Now another important component of SQL 3 standard is SQL PSM, that is persistent stored modules. Persistent stored modules. PSM is the short term for persistent stored modules. It specifies the facilities for partitioning an application between client and server. If an application is being submitted to the system, and as you know, when we are dealing with database application, some portions will be executed at the client side and some portions are executed at the server side. Normally maybe the data is present in server, so we need to access the data from the server. Only the data is required in our client side, so the request for data will be passing towards the server, and only the database access is required. Suppose for example I am saying, and in the client side all other operations or all other execution will be happening. So the persistent stored module provides the facility for partitioning these two sessions, which portions can be executed at the client side and which portions can be executed at the server side. So that is done by persistent stored modules. So it enhances performance by minimizing network traffic. So for example, if you want to execute a small portion from the server, if the PSM is not dividing that entire task into the client and server separately, what is happening is the entire code is to be transferred to the server side, so that it will be having a heavy network traffic. So in order to avoid that, this PSM will support the division of the entire input code into two different sessions, one for the client and second for the server. So it will be divided properly so that the total network traffic can be reduced. So that is the usage of persistent stored modules. Then, as you know, another component, that is SQL binding. SQL binding is dealing with embedded SQL. So how we can deal with SQL that are present within an application program. So assume that we are having an application program, and in between that application program we are having some SQL statement. So this is a program written in Java, and in between we are having an SQL statement available. So how we can bind these two, the traditional application program and SQL, how we can bind these two? That is done by using SQL binding. So normally Java program is having a syntax, SQL is having another syntax. So in normal flow it cannot be executed together. So there must be some provision for binding this SQL with the application program that is being mixed for a particular requirement. So SQL bindings are very important. As you know, in JDBC and all Java database connectivity, we are having this embedded SQL as part of Java. So there will be some provision for binding internally within that database system. So SQL binding provides this combination of SQL and different application programming languages. Similarly, another component is SQL temporal. It deals with the historical data. I have already mentioned that the temporal database deals with the data that is already being stored within the database in terms of the date and time. So temporal is indicating the exact time, history, at what time, on which day one particular event, one particular object was inserted into the table, one particular data or row was inserted into a particular table. So if we are maintaining this temporal information, this data can be very much useful for certain types of application. So by using SQL 3 standard, we can deal with this historical data, and this historical data is maintained by using SQL temporal component of SQL 3 standard. So we have seen SQL Foundation, then SQL call level interface, then SQL persistent stored modules, then SQL bindings, then SQL temporals. So these are the various components of SQL 3 or SQL 99 standard. I hope it is clear. So it is very important to discuss or describe the different components of SQL standard with the support of object-oriented features also. Now next one, the object relational support in SQL 99. So we will see SQL 99 alone. So previous one we are discussing about general features of SQL. Now the object relational support in SQL. So as I have mentioned, SQL 99 was a subset of SQL 3, which is dealing with object as well as relational database concepts. So we will see what are the different features that are added to SQL 99. So we can see a type constructors. We have discussed about type constructors in our previous session. That is, type constructors are used for specifying certain complex objects. You might be remembering the different type constructors like tuple, struct, array, list, etc. All these are type constructors that are used for creating complex objects. So SQL 99 also supports various type constructors for creating such type of complex objects. So we will see some examples of type constructors later. Similarly, SQL 99 supports the mechanism to specify object identity. So object identity is one of the major feature of objects in object-oriented database system. So object identity is very important. So how we can create an object identifier? So SQL 99 is having a provision for providing this object identifier so that every object can be identified uniquely. So object identity concept is added into SQL 99. Then next one is there is a mechanism for encapsulation of operations. Encapsulation of operation means grouping all the operations required for a certain object. So grouping all these together is usually in the form of class in C++ and Java. Similar like class, we can create some types in the case of this SQL 99, where we can group all the operations that are required for a particular database. So encapsulation is another feature added to SQL 99. Now similarly, a mechanism to support inheritance. So as you know, the object-oriented system, object-oriented database or any object-oriented language, inheritance is a major feature. So SQL 99 also supports inheritance, which relates two different types or two different classes. In language terms, we can call it as the relationship between two classes. One class can be created by taking the properties of another class. So that is usually called as inheritance. Now inheritance can be of two types, that is by specifying specialization and generalization. Specialization is our usual inheritance. One class is created from another class. So this new class will be having its new properties plus the properties taken from the previous class. That is called as specialization. Now generalization means more than one class take the properties to form a generalized class. It can be considered as an interface concept. So some generalized operations or indicators are available for more than one class in a particular generalized structure. Okay, so it is almost similar concept, but there are some slight difference between specialization and generalization. Now let us see some of the type constructors used in SQL 99. There are basically two types. One is a row type and second one is an array type. Row type and array type. So one type constructor is row and another type constructor that we are going to use is array. Now these two can be called as user-defined types, user-defined constructors, user-defined data types that are present in SQL 99. Now we will see one example for a row constructor type, row type. How we can create a row type. So let us see this simple example. Create type name, that is row type name, as, then within square bracket I am giving this row, ROW, then within this parenthesis I am providing the component declarations, then I will be having a semicolon also. So create is the keyword, type is the keyword, then there is a user defined name for the type, row type, then as is the keyword, then within square bracket I am providing row. Why it is given as square bracket? Because it is an optional part. If we are avoiding this portion, by default this type will be considered as a row type. So that is the specialty. So create type, row type name as row, then within parenthesis the different components to be declared, then put a semicolon. So we will see one example, then it will be little more clear. Create type, address type. I am giving a type name address type as, I am not giving this row here because by default it will consider this as row type if you are not providing anything. So create type address type as, then within parenthesis I will be providing different component declarations. First of all, street varchar of 45. You might be knowing what is varchar, variable character. In traditional SQL also we are using this varchar. The same data type we are following here also. Street is the attribute name, varchar, then within bracket the size of that street attribute, that is 45. Up to 45 characters can be permitted for this street. Okay, comma, city is the next attribute, varchar of 25, comma, zip code char 5. Closing the bracket, then put a semicolon. This will create a new type. It will create a new type which is called as address type. So what are the features of this address type? So an address type will be having a street, city and zip code. Then this is a user defined type and we can use this type in some other situation. So we will see that where we can use this address type. So before moving into that, we will see what is an array type. So this is an example for a row type. What is a row? How we can specify row, then which is an optional, then how we can create a new type by specifying all these components. Now we will see how we can specify an array type. Now an array type is specified for an attribute, so it is normally given for a particular attribute, but row type is given for an entire type, which is common. But an array type is given for an attribute whose value will be a collection. Array, as you know, array normally consists of a number of values. So for a collection only we are using. For a particular attribute, if you are having a collection of values present, we can use the type constructor array. So we will see one example. Create type company type. For example, this is the name of the type, company type as. So this is also row type. Within parenthesis, I will be providing company name varchar of 2, comma, location varchar of 20. Now we are going to specify this array along with location, array of 10. That means in this company type we are having 10 locations available with the type as varchar of 20. I hope it is clear. The company type will be having a company name and the different locations of that company. So for a particular attribute, we are providing an array type constructor which provides the number of that particular attributes present in the type company type. So row is given, which is part of the entire type. Array is given as part of a particular attribute. Now in order to access a particular component, so dot notation can be used for accessing a particular element like company name. How we can access a company name? If company 1, if comp1 is the object, company 1 dot company name. This is the way in which we can access the company name of company 1, which is of company type. If you are having an object called as company 1, comp1, and if I want to access the company name attribute or property of that, I can use company 1 dot company name. I hope it is clear. It is somewhat similar to the usage of C++ classes and objects. So here we are simply avoiding class with type. We are creating a new type. There we are creating a class name. Here we are creating a new type by specifying create type name as default row. Then within parenthesis, attribute 1 type size, comma, attribute 2 type size, comma, attribute 3 type size, comma, up to n number of attributes. Along with each of these attributes, if these attributes are having multiple or it is a collection of values, we can provide an array type constructor also along with this location. In this particular example, this location with array of 10. So it is permitted for having 10 number of locations for each of these company. Now we will discuss about object identifiers. How we can create object identifiers, how we can do object identity. It is by using a concept called as references. Now listen, a user-defined type can also be used to specify the row types of a table. So in the previous case we were discussing about each user-defined type. First one it was address type. Second one it was company type. Separate user-defined type was created. Now these types can be used for creation of a particular table. We can create a particular table. So how we can use that type which was already created in a particular table. So how we can do that? So we will see one example. Create table. So now look at the difference. We are going to create a table. So normally a table means we will be having a number of rows present. previous example we are discussing about only a single row. So if you want to create a table with multiple number of rows, we can directly create table company. Company is the name of table of, that is a keyword, which type? Company type, which was already created as a user defined type in the previous slide. So create table company of company type. So that part is over. Then within bracket ref is, that is reference is, this is a syntax to be followed. Ref is company id, then give a space. I have given system generated. So when we create a table with company type constructor or type, new type, this table structure will be created. Here the ID, the identity of that table can be created by using company ID, that is reference is company ID. So company ID is considered as the reference for this particular table, and this company ID, so this is the way in which this value will be generated. The company ID value will be generated. I am using system generated mechanism for the company ID creation. Okay, so just listen. Create table company of company type. Reference is company ID, which will be created by system space generated, comma, then I will be setting a key, primary key, company name. So company name is taken as primary key for this particular table. So primary key is used for identifying that relation or table. Company ID is the system identifier or unique identifier for the different tuples created within this company table. A company ID, a system generated ID for this company, the new company that is being created with some set of rows. So one ID will be assigned for that particular company. So this is unique system identified identifier. This primary key is the different attribute which can be identified uniquely, or that is for the entire company table we are using. It is just like a normal primary key, but this company ID is for. So if you create one more table, like create table company 2 of company type, it will be given another ID, for example 2. It will be generated by system itself. Now if you create one more table with this company type, which will be given another identifier, maybe 3, which will be created automatically by the system itself. So that is why the system generated is given. Okay, so you can see how we can specify this object identifier. We will see that reference is object ID attribute. So which attribute can be used for this object identity. Then the value generation method. After putting a space, we can see a value generation method. A value generation method. So the various options for this value generation methods are: first one is system generated, which was used in this particular example, and it can also be a derived also. Derived means it can be derived from some other value that is already present in the table. So two mechanisms for value generation method in the table creation. I hope it is clear. Now we will see attributes as references. How we can give a reference of one attribute to some other attribute of some other relation. It is just like a foreign key concept. When value of one table is depending on or one type, one attribute, one type value is depending on the attribute of another type. So it is just like a reference in foreign key concept. So the component attribute of one tuple may be a reference. See one example we will see. Create type, employment type as. So this portion is same, exactly same as the previous one. Create type, employment type as, within parenthesis, employee is the attribute, first attribute of this employment type. Employee, ref, reference of employee type, scope, employee. So one attribute of this employment type, that is employee, which is a reference to employee type of another type, employee. So employee consists of employee type. Now this employee is referred by the employee type of relation or type employee. So that is why this syntax is given. Employee is referred by employee type, and scope, this is from, this employee type is taken from employee type, comma, one more attribute is given, company, reference is company type, and its scope is company. So this company attribute is being referred by company type, which is from another type, company. So the keyword scope specifies the table whose tuples can be referenced by a reference attribute via the dereferencing notation. So if you want to access that particular element, for example, assume that E is an object being created for employee, e.company, arrow, which is also called as dot company name. So for employment we are having E as an object, employee E dot company name, E dot company name will provide. So this company name is present inside company, which is not given here, but here for this company we are giving a reference to that company type. So company type of company consists of this company name. So automatically this employment type can refer to the company name of company, which is another relation. I hope it is clear. It is almost similar to the foreign key concept. The value of one type is depending on the value of another type. Now let us see encapsulation. What is encapsulation? Encapsulation means the wrapping up of data or attributes and operations into a single unit, which is a construct similar to class in C++. Now users can create a named user-defined type. The user can create a named user-defined type with methods and attributes. So we can call the term encapsulation when we are writing both attributes as well as operations together. When we mix all these elements together, we can call it as encapsulation. So in the previous example we were discussing about only attributes. Now we are going to add some operations also into the type that we are creating. So we will see one example of encapsulation. Create type name, then within parenthesis the list of attributes with its type and size. Then we can have some default equal and less than methods, which is common. Normally when we use this SQL 99, we are writing some equal and less than methods as a common methods. It is not mandatory. If it is there, that can be declared here, and we can declare other methods also. Then put a parenthesis close and a semicolon. So list of attributes and list of methods, method declarations will provide the encapsulation in SQL 99. Now we will see the syntax of providing a providing a method, that is method name, method name, then the list of arguments, then returns return type, semicolon. This is the way in which we are providing a method. Method keyword, method name, parameters, returns return type, semicolon. So you'll see one example type. Create type address type as street varchar 45. The previous example itself, city varchar 25 comma zip char 5. Then attribute portion is over. This parenthesis can be combined together, means all these are together. If you want to separate these attributes, we can use this parenthesis. So this is not the exact syntax, we are randomly taking this. So the attributes are being defined. Then I am going to declare one method space apt underscore no without parameter. This is the method name without parameter, which returns a character char of 8 semicolon. Now it is clear, I think. A set of attributes and a method declaration. It forms an encapsulation in SQL 99. Now we will see inheritance, another property of object relational database. Inheritance, it is usually specified by using the keyword under. In Java we are using extends. Similarly in SQL 99 we are using under keyword for inheritance. I will see one example. Create type manager type. So I am going to create a new type, manager type, under employee type. So only difference is create type, new type, under existing type. Create type, manager type, under employee type, as, then within bracket provide the attributes for manager type, that is department managed, its type and size, close it, semicolon. Now this manager type consists of all the properties of employee type as well as the manager type, that is department managed also. So the manager type inherits all features of employee type, and it is having its own feature, that is department managed, which is exactly similar to our C++ and Java inheritance concept. Only difference is the usage of under keyword. Now other operations and new features of SQL 99, it can use a with recursive by using with recursive syntax or statement. We can execute some certain type of recursive queries, that is a query that is to be looped more than once. Recursively, if that query is to be followed, we can use a statement called as with recursive. We are not taking any example now, just understand one concept is there called as with recursive. Similarly, we can do some authentication modifications, that is user accounts may have their role that specifies the level of authorization and privileges. We can change the role, we can provide some authorization to some user, we can provide some privileges to some basic authentication changes can be done with SQL 99. Then it also consists of another feature called as trigger granularity, which allows row level and statement level triggers. The support of triggers is there in SQL 99, which specifies the rules which can be executed automatically as part of the execution of a particular event or particular SQL statement, which will happen automatically. So trigger granularity is maintained in SQL 99, and SQL 3 also supports. So we are generally discussing about SQL 3. SQL 99 is a part of SQL 3. So these two can be mixed. So SQL 3 also supports some programming language facilities also. So these are the additional features of SQL 3 and SQL 99. Now we will see, so far we were discussing about the object relational features of SQL 3 and SQL 99, specifically for SQL 3 and SQL 99. Now we will see some object relational features of Oracle. So while explaining this Oracle object relational features, we are discussing about the additional features added to Oracle. So Oracle is another database management system which is having more advanced features. So it is having all the traditional features of SQL 3 and SQL 99. Along with that, it is having some additional features also. So if object relation features of Oracle is being asked as a question, you can take the features of SQL 3 and SQL 99, all the features. Along with that, you can add these one or two features also. So that is specific features of Oracle. So Oracle uses a particular concept called as V-array. V-array. We are using a statement called as V-array for representing multi-valued attributes. If you want to represent a multi-valued attributes, we can use a V-array concept. So we will see one example, different situations. So these are the different set of statements that can be connected separately. Okay, so first one, we are going to create a new type called as font type. Create type font type as object. Now look at, in Oracle we are using an additional term, that is object, for the creation of a new type, which was not there in SQL 99. There it was directly being created like create type, type name as. But here create type, type name as object. Then within the bracket we need to specify the attributes, its type and size. Then put a semicolon. So create type font type. So I am creating a new font type with font number of 10 characters. So it is clear, one new type is being created. Now I will be creating another type, create type font list type as V-array of 5. So I am going to create a new type which is taken as a V-array of 5, means it is an array of 5 elements of font type. That means with font type features, I will be creating a new type with 5 number of font types. That means 5 font numbers can be included within this font list type, which follows the font type type. That's all. A new type is being created as a V-array of font type type. Now I will see how we can utilize this font list type. Now I will be creating another type, create type customer type as object, customer name varchar 20, comma, font numbers, font list type, font numbers. So the second attribute is font numbers. A customer will be having maybe a maximum of up to 5 font numbers. So this is a multi-valued attribute, font numbers, which follows font list type. Font list type, what is font list type? Which is a V-array of font type, and font type is having font number with 10 characters. I hope it is clear. Now we will see, we will create a table, create table customer of customer type. So based on this customer type, I am going to create a new table, create table customer of customer type. Now if I want to select some elements, select customer name, comma, phone numbers from customer, will produce or will select each customer and its corresponding phone numbers from the table customer. I hope it is clear. So we are creating a font type. Then I am creating a font list type, which is a V-array of font type. Now I am creating a customer type, that is we are creating another type where within the attribute I can use this V-array type. Then we can create table on any of these type, and we can select the different elements by using select statement. So this is the usage of V-array. V-array is an important question that can be asked as a short question for a 5-mark question, the usage of V-array in Oracle. So this point can be added as the additional feature of Oracle or object relational feature of Oracle, other than the previous features which was already discussed. So V-array is one of the major feature added to Oracle. Then other than that, Oracle also deals with large objects. It can manage large objects, like some examples are given, like RB-lob, that is binary large objects, then character large objects, then binary file that is stored outside the database, and fixed width multi-byte character large objects. So in order to deal with all these larger objects, normally traditional SQL or SQL 99 does not deals with these larger objects, but Oracle is having some support for dealing with these larger objects. Binary large objects or character large objects means they are dealing with big documents or big images, etc. All these can be possible with Oracle database also. So two features added to the Oracle than the traditional SQL3, that is VArray and managing large objects, various large objects. So we were discussing about object relational and extended relational database features added to the traditional SQL 3 and SQL 99 standards. That means traditional relational features and object features added to SQL 3 and SQL 99. We have seen several features like encapsulation, inheritance, then object, creation of a new type, type constructors, etc. Then we have seen some extended features of Oracle with some additional features like VArray and managing large objects. So that is all about object relational features of SQL and Oracle. I hope it is clear. So we will wind up now. In the next class we will start with the new module. We will discuss about some triggers and other additional features of database, some advanced features of database systems. Thank you.